Ever wondered how shopping malls like Sephora or Macy's target the right customers with the right offers? That's exactly what customer segmentation does. And today I'm going to show you how using the mall customers dataset. We'll go from raw data, real insights, and cluster based strategies using Python, visuals, and real world logic. Let's jump in. So you can find the data set here in Kaggle with small customer segmentation data and download it. And then today we are going to work in Google Colab. So I've connected Google Drive with a Google Colab and uploaded my data set in Google Drive and then loaded it using pandas. Now, as we have imported pandas, now let's start by importing other libraries that are required. Let's import matplotlib and then import Seaborn because this tutorial has a very strong visualization requirement. And then as we are going to perform clustering of what kind of customers or what group of customers are shopping with us, so we use a k-means cluster for this. So we use pandas for to load and manipulate our data, Seaborn for clean and powerful visualization, and k-means for clustering algorithm. Let's run this. And then as we have okay here this error means, so the capitalization or the font size or the font is a matter in Python. So as we have loaded our data set, this data set stimulates mall visitors with details like age, annual income, and spending scores. Think of it as your loyalty card database. And then let's have more info about the database. So df.info. So we are checking on the null values. No. Oh, great. And the data type seems all good. And income and spending, wide variety. A perfect database for segmentation. Let's see the describe. Yeah, so the age and 18, the age ranges are from 18 to 70, and the annual income are from within a perfect range like 130k to 15k per annum maybe. Now let's start by plotting a age distribution graph. Figure size fig. And using Seaborn, let's use this scatter plot where the x-axis is the annual income and the column name, we need to give the exact column name for it to get connected. And next, the y-axis is the spending score. Oh, I'm sorry. Let's I've just told about the age distribution, right? Now let's plot the histogram for this one. Hist plot df of age wins, and the distribution is equal to true. Plt dot title of this graph is age distribution. Plt dot show off. So Yeah, we can target Gen Z differently from the baby boomers. Segmentation starts here. So we are having most number of customers with this particular age groups, and yeah, so there is a decline in the trend. And next, move to the annual income versus the spending score graph. PLE dot figure fig size is equal to 10 comma 6. SNS dot scatter plot of x is equal to annual income. And spending score of 1 to 100. And then gender and data is equal to DF. And now let's have the title for this graph to be income versus spending score. And let's show the graph that we have plotted. So the value string, but the data was not passed, so let's give the exact column name for this one. Okay, let's copy it from here and let's try it again. Okay, it's because I haven't, and there is, yeah. So here is our plot for income versus spending score. Some high income people are, people spend very little, maybe they are price conscious. Others, like with a low income, spend a lot, maybe they are trend driven. So this is where clustering helps. Like we are finding the people with low income are spending on an average more, and with respect to the gender, there is a lot of females maybe. Yeah, let's check on that one. And next, let's also focus on the feature selection for clustering. We are picking only two features that we are going to work on, and they are annual income and the spending score. So x is equal to df of annual income small k spending score and the two most interpretable features to visualize clusters easily. Later you can scale this up and with more variables like age, gender, etc., right? We'll try that one. Next, we'll use the elbow method to find the optimal k. Okay, so let's see, create a list for this one for finding the best k for this particular data set and use that in clustering 1 to 11. So we are considering k values to be 1 to 11, and then k means creating a variable k means and calling the custom function k means for clustering, considering the number of clusters to be 1 because we have only, and k hyphen means plus plus. Okay, and the random state to be 42. K means dot fitting the our data into, and then appending all the required inertia underscore. So the error is in this state and got an unexpected, it is in it, okay, in it, not. And now let's plot the graph for this clustering and decide which k value is better. Sorry, figure size is equal to 8 comma 5 and plt dot plot of range 1 comma 11 comma wcss and marker, considering the marker to be O for clustering, okay, and plt dot titling the graph that we are going to plot, the elbow method. Plt dot x labeling the x axis to be the number of clusters, and plt dot labeling the y axis to be wcss, and plt dot show off printing the plot. Let's see what this wcss is holding, and oh, it's holding the same value. Oh, I'm sorry, this isn't 1, this is I. And now let's see the values. Okay, seems like in the elbow method we choose k is equal to 5. That's where the curve bends, right? So this minimizes the intra-cluster variance and gives, interpretable segments. And now let's build the k-means model. So here to differentiate between the variance between each cluster and to get a perfect cluster size, we need to decide how many groups, or we need to decide how much the data or how many groups we need to form with the given particular data. So in this graph, the curve is bending where the k is 5. See, you can see slight decrease over here, but the middle point is k is equal to 5. So we consider the data or divide the data into 5 groups for having better clusters or grouping the data in a better way. So let's write the same again. K means clustering, and n underscore cluster this time is equal to 5, and in it is equal to k means plus plus. This k should be smaller, and the random state is is 42, and then y underscore means is equal to k means dot fit underscore predict of passing the x values, that is the income and the spending score that we have considered as features, and then clustering it with y underscore k means. I think it's because of this one which is not defined or was unexpected keyword n underscore clusters, okay, and y underscore k means is not defined. Yeah, now we have added the cluster label back to our data frame. Each row is now grouped based on the behavior. Now let's plot the graph for clusters and visualize the segments that we have clustered. Okay, plot figure fig size 10,6. This is dot, and SNS dot scatter plot K, and then dollar, and Y of spending score again 1 to 100. Hue is equal to cluster this time, and palette is equal to set to, like the different colors, and the data that we are passing is the DF. Now let's label or title our graph is customer segmentation segments at least. Okay, and then plt dot show off. Yeah, so the cluster 0 are high income, high spending people, that is this range. These are considered to be the VIP customers, and the cluster 1 is these are also high income. The cluster 1 is considered to be the high income and high spending people and are the VIP customers, whereas this is high income and low, the pink color, or the cluster 3 is considered to be low income, high income and low spending, that is their cautious rich people. And the cluster 4 is low income and low spending. These are considered to be minimal shoppers. Okay, so the these are the average all-rounders, and these are low income and high spending people. So the cluster 2 is low income, high spending people, the average all-rounders, and high income, high spending people, high income low spending people, and low income low spending people. So this is how we have clustered our group of customers and segregated based on spending score and annual income. You can add more features like age, gender, and so from this segmentation we can draw real time strategy, or we can build a real world like you can now send discounts to the most popular customers like high spending and high income people, and average all-rounders, and some for low spending, low low income and high spending people. So, and then we can also understand why the customer group 3 is not spending even though they are having a high income. So the real-time decisions using this business case can have personalized marketing, like target high spending clusters with loyalty perks, or you can do a store design, place expensive products in a route where clusters 3 and cluster 1 are around or they use, and also mix the products like budget items for clusters and luxury items for cluster 4 and not luxury items for cluster 1 and cluster 3, right? So the budget items for this cluster 4, right? So we have used the simple data and uncovered rich insights. That's the problem of power of segmentation. It's not about building the most complex problems, but about the making smart and customer centric decisions. In the next video, we'll try hierarchical clustering and bring more features like age and gender into the play. Subscribe and stay tuned. Thank you.